Hi, good morning.
Hey, good morning. Yeah, and I think like after our four have a discussion, we kind of settle
Mm.
down all the design and start to do the housing. Yeah, and
Okay.
for me, I'm in charge of the health and the housing, and I think I basically finished most of it, but only have one slight problem. Yeah,
Oh,
about the
go ahead.
rotation of the fan. And
Mhm.
is that okay for me to share my screen and
Sure. Go ahead.
okay? Oh, you're forbidden.
Oh, sorry.
Just
My bad. Now you can do that.
okay. Uh, mm, yeah, it's like I think you can just maybe have a basic look. Just as you can see, it's gonna do the
Mm.
peak and start to cutting.
Mm-hmm.
Yeah, yeah. So first cut. Yeah. Here is the problem. Yeah, the second cut is kind of problem, and yeah, it's to the edges cut from the both side, and
I like
yeah.
it with the last one. It actually goes from up to down rather than down to up.
Mhm.
Okay. So which one was the problem?
Okay, so the last cut is that just the cut it off. So the problem is here. Wait. Mm, uh, I think it's. Let me show you.
Mm-hmm.
Okay, this one.
Mm-hmm.
It's actually from this point, like cutting this. Yeah, cutting this side. Yeah, but actually, I think instead of cutting this face, the surface is just cutting through the medium, and it's this one, this arrow. I
Okay,
think
so
there's some.
wait a second. I need to just clarify which side is cutting. Are you talking about cutting this section that I'm drawing right now? I'll do the
Yeah,
second. It shows up. Do you
yeah,
see it?
yes.
Okay, interesting because it doesn't show it in my computer.
Oh, really? But I
Mhm.
can see it.
Okay, good.
Yeah,
So it's that side. Okay.
yeah. I think it's more clear. I just yeah.
Mm-hmm.
Can you see
So
the
when
green
it
part?
yes. Okay, so what was the problem there? Why isn't so it's not
Like
cutting it?
no, it's cutting from the middle. Actually, it's through
Oh,
it. Yeah, I
instead of
think you
starting from
understand.
here, it's starting from here. You mean
No,
this?
no, no. Uh, it's I think uh remember this surface and actually the mm, the as you can see it's
So
cutting
my
from
suggestion is
this.
to actually just minimize your grasshopper and then open two views of Rhino so I can actually see at the same time both of them.
Okay, as you can see, like it's actually should cutting this surface, this one. Yeah.
Mm-hmm.
Uh-huh. But instead of cutting this kind of surface has some kind of angles,
Mm-hmm.
it's just cutting immediately from the middle, as you can see.
Mm. Okay. I think just the rotation is so basically you
Yeah,
mean that it should be rotated for like 90 degrees or something like that.
yeah. As
Okay.
you like, yeah. I think it should be yes, some
So
90
can
degree.
you zoom in on the targets?
Wait, think I can. Hmm,
Yep. There.
yeah. Uh,
Because it's grasshopper, you can. Okay. So okay. Good. There.
mhm.
A little bit further. Okay. So do you see what's happening here? So just click somewhere else. Yeah, click somewhere else because okay.
Uh-huh.
So first of all, you have duplicated targets. Why do you have two targets at the same time here? Because these two targets are not aligned.
Because I'm trying to do the
Okay,
rotating.
so hide the things that you don't need so we can actually visualize which parts are the actual targets that you are cutting.
This one. Mm-hmm.
Okay, so whatever you don't need, just hide it.
Okay. I already had it, so there is only one
Okay,
target.
okay, so right now you see that this is the X, this is the Y, and the Z is actually facing down. Okay,
Yeah.
that's not good. So something is fishy here. Can you zoom out so I can see like the targets on its left? Just a little bit zoom out.
Oh.
Not that much.
I'm sorry.
So
This
you can
one?
actually, yeah, good. So here you see that these targets on this side. So this is X, this is Y. And if you use the right-hand roll, Z is up here. Okay. But here you see that Z is here, X, Y, actually X is here, Y is here, and Z is here. So you can see that your targets are actually not only upside down, but they are also 90 degrees rotated. That's why your robot is doing the wrong job. You need to flip these targets.
Yeah, I flip.
Okay, so the flip one is right now hidden. So we see something else. So actually you should unhide, yeah, preview that one and hide everything before it. So I can actually make sure everything is correct.
Think okay. Oops. Yeah, this one.
Okay, now let's see what do we have. So we still have two things here. I think there's one better solution. Can you send me this file so I will open it on my computer and then we can discuss it? Because right now it's really hard to explain it. Okay, just send that file for me, share it somewhere so I can grab it. So let me stop that one.
Okay, so I'm just stop sharing and
yeah, that would be a good idea. Hello everyone. Everybody is here right now. So I'm just trying to figure out what's the problem with the file. And once we're done with this file, we can actually get into the topic of today, which is Machina, real-time robotics, and other stuff.
Okay, so I'm gonna just
send me the email. Yes, that would be awesome. Okay, so meanwhile, student view. Okay, so I'm going to share my screen meanwhile. Okay, so for today, as I mentioned, the topic is going to be about real-time robotics and real-time communication with a robotic arm, which is opening the discussion for a little bit challenging applications of robotics in human-computer interaction. So in order to do the job for today, you need to actually go to your files, and then in Machina, number 12, there are 3 files here. So for today, first, please download this one, Machina Bridge version 8, actually version 0.8. Download this file and open it in your computer. So I'm going to download it. And whenever you have sent the file, just let me know so I can actually see it there. Okay, so open this file. It's a zip file. As you can see here, it's a zip file. And there would be this folder inside the zip. You just copy that folder and bring it somewhere, for example, into your desktop. And make sure that you're not copy paste, like you're not opening this file from your zip folder. You must copy it somewhere.
Raymond, I will already send you. Yeah.
Okay, is it done?
Yeah, it's done.
Okay, so keep that Machina file over there. I'll get back to it. But just remember, download the 3 files that we have here. Where's that thing? Okay, so please download these 3 files. Probably you're not going to use this one, but this one and this one, these are the 2 things that you need to download. And I will get back to that one in a minute. Okay, so let me just double check your files. Okay, so we have the grasshopper file. How can I download everything together? Download and download. Okay, good. So let's see what we have here. Okay. Okay, it's here. diffuse. Okay, it's going to take a while. It's a heavy file. Good. Okay, so these are the targets. And I can safely assume that this is the place that you are working on. Okay. So let's see what else do we have over there. So you see that there are like two sets of targets here and they're all rotated on top of each other. So there might be some other files. Okay, so this is the one that you use as your target. And this is, let me see. Okay, so this is X, this is Y, and this is Z. It seems this one is legit, no problem. So let's see what else do we have here. We have a bunch of targets here. So I just want to compare them together and see what's your tool definition. So here, if you have no problem with these cards, probably you should not have any problem with these ones either, because they are only 180-degree rotation of each other. And then let's see what else do you have here. All the targets here. Okay. Okay, so you have a bunch of targets that each are in different situations. Yet they are all in good shape, and for some reason. Okay, so let's see what's wrong here. So I'm going to play with these two cards here, this one and this one. So let's detach them from this group. So we can play with these two. Okay, so let's see which part of this whole toolpath is the problem that you have. So I think it was one. Am I correct? Let's see. So I'm going to keep this perspective view as well as this set view, perspective view. Where's that? Okay. And see what's going on here and what's going on here. Okay, so I'm going to hide everything else that we don't need here. And the only one that we need is this one. Okay, so let's assume that this is a toolpath that we need to work with. And the number of targets that we have is not 120. So let's keep it around 25 so we can easily manage everything. Now let's see, what does this robot do? Okay, so the robot is basically turning everything 90-degree rotated while we have these targets that should not be like this. Okay, now let's check with some other toolpaths that you may have here, like this one. Okay, so these, okay, let's see what will happen with these ones. Strategically located there. Huh, doesn't work with that one. Oh, sorry, my bad. It should actually like this. So for this one, we have the same issue. It's also cutting this from this side. So this is also, oh, but for this one, got it. So I think, so this is the same cut, am I correct? Do you want to cut these sets that you see in green in the same way that you cut those other ones or not?
Yes, the same way.
So if you have any problem with that one, this one is also challenging. First of all, is this a geometry or it's just like, okay. So this is this surface that you're trying to cut. Let's put some, okay. This surface that you're trying to cut is this one. So for this, it makes sense to cut this whole thing from this angle that I'm seeing. But for this one, which is slightly different, which is this point, and where's the last piece here? For this one, you need to have a different angle, which is perpendicular to the whole thing. Okay, so I think the only thing you need to do is to actually rotate your targets around its plane. So have you rotated anything? Yes, this is the one that you need to rotate, and you're not using degree. That's one of the problems. And keep this one as 90 and minus 90 as the limits. And maybe it should be correct number. And then you rotate it for 90. And that's it. Now when you cut, you see that it's doing the cut that you want. You just need to do the same thing for the rest of it. Is that clear? So the only thing you needed to do is to actually rotate it for a correct amount. So I'm going to delete whatever you don't need here. Yeah, that was the problem. And remember, this rotation value must be angle in degrees, not radians. By default, it's radians. So 90-degree rotation in radian is pi divided by 2. So it's going to be a really, really crazy number, 3.1415 something divided by 2. But if you convert that one into angle degrees, then it's going to be an integer number of 90. So if you have used the same trick anywhere else, which I think that you should do, for example, for this cut also, like the one on the other side, for that one, you should also have some similar ideas. But no, that's correct. For that one, you need to do this, and then you are fine with this. Also for this cut, you need to have the same 90-degree rotation. Make sure that it's correct, and then you're fine. The other thing that you can actually work and clarify this whole workflow for yourself is to let the robot hold the geometry, the actual geometry, instead of this block here. So where did you define your work object tool? Let me see.
In the beginning, you can just zoom smaller for the grasshopper.
Is this no? I actually the one that you have the work frame. Okay, so wait a second. That's okay. More reference system, and somewhere in the reference system you should have the geometry of the tool and other stuff. Why can't I find that one? Or actually, yeah, one here. I could see it for a second. Oh, is it here?
It's on the.
Is this one? So my suggestion is to actually, instead of just using that geometry, that form, do you have the original geometry of this one somewhere in your file? Where's that?
In the layer. I think you should turn off the
layers, and in layers, cut elements. Oh yeah, it's here. Okay, so I'm going to do some extra stuff here. So I'm going to bake this one. And oh, I don't need that part. Yeah, I need that part. And then I'm going to scale this thing from here to somewhere maybe here. And then group, and group. Is this everything? Yes. So
this is so smart.
What was that?
This is smart.
Yeah, you can actually see what's going on here. So I'm going to hide whatever we have here. Oh, good. We don't need these things for a sec. Okay, now your robot is holding the object that you are cutting. So my suggestion is for now, like just observe and make sure that it is cutting the pieces that you're looking for. And whenever your robot, your system is not zooming on the object that you want, just select something in the scene and select zoom extend, zoom selected. It's going to show you everything. Now let's go back and check all of your targets. So not here, but actually somewhere closer to down here. So I think this is all you got, like toolpath filter. Okay, so let's see if it's doing the job correctly. So I'm going to just close this because we don't need this. Okay, so let's go for the first cut. Yep, so let's start from scratch. It's coming here, cutting the right thing, moves in the correct direction, no problem. And then goes up. I'm going to increase this number into something meaningfully larger. And let's go for 50. And again, it goes down. Oops, what was that? It's cutting the same thing again. Okay, so is this correct one? Yes. No. Is this? No. Something is fishy here. The angle is not correct. I think that's the problem with that rotation. So did you use the rotation here again?
No, actually, I only use rotation.
That's a little bit odd. So it's target number 42. So let's see 42. Where is that 42? So this is the order. I think it's in number 3 here somewhere. Okay, that's odd. It shouldn't, because like it is just basically a little bit error in the rotation thing. Maybe the way you define the surface and the curves is not accurate. Look at here. All the stuff that we have here. Yeah, these two curves. Okay, I think there might be something wrong here. Oops, that was too much. Okay, I think you need to check that one and see what's wrong here. Something is inaccurate. Because like I see you're following the geometry. Maybe when you define these points in your curve, maybe they were not exactly matching the target that you were defining. I saw a little bit of discrepancies between the geometry that you have and the snaps. That might be it, but we need to double check that one. Anyway, it seems like the direction of the cut is correct, but it needs a little bit more of investigation and see why is it not exactly matching the orientation. Okay, do you see this? This is also a little bit challenging. So let's go for target from 50 to 100. The reason I'm making these like 50 steps is because I want to have complete control over everything. Okay. So
actually, it's like kind of 135 is the whole thing.
Yeah. Okay. So it's doing something that I'm not sure what's going on here. This one is definitely not the one you want to cut. So maybe I think you somehow duplicated something. And okay, this one seems legit. Is it cutting? Yes. You see that it's accurate. So you see half of this wire here in the file. The other one was slightly off center. Okay, and then somehow everything is getting cut twice. And some of them are not accurate. Okay, this one is also correct. Let's go between 100 and 150. I hate this sound when grasshopper makes it. Okay, this is correct. And let's see. Oh, that one is a little bit challenging. So do you see this one? The robot is here. Then it goes there. This means that from point A, is it drawing? Yes. from point A to point B, it's going to actually cut through your model. So you need to increase the Z value, okay?
Okay.
So let's see, between 111, which is basically your object is here, and 112, your object gets there. You see what happens? Your object is actually going to go through this wire, and then half of it is going to be cut. And I can safely assume that the robot is going to go full speed from this point to that point. So everything is going to be a little bit challenging. So my suggestion is to actually increase those like safety spaces as much as you can. So the robot is not going to go through the wire by itself, okay? So this is another cut, which is basically your final cut. Then your object is going to drop down. Okay, one piece of advice. Instead of, for the last cut, instead of going from left to right here, you see that the robot goes from left to right. It means that at the end, it's going to drop your object here between the table and the robot. But if you go from this direction to this direction, from right to left, actually, oh, I was wrong. This is actually a good one because right now, if you cut it, your object is going to, no, I'm right. So if you go this way from right to left, your object is going to drop here. So somebody can actually stand on the other side and just grab it while it's being fallen down. But I think it's not a good idea to have somebody on this side between the table and the robot. So for the last motion, just flip the target, like reverse the order of targets. So you're both going to get rid of that, Z value that goes through your object, and also you're going to have a clean cut. Your object is going to drop somewhere that you can actually pick up. Okay, go ahead. Any question?
Yeah, just you mean like for the last pass and just going to like reverse on the other, so it's kind of going to be fine.
So where is the last one? Is it the last one? Probably.
It's on the top, cut 8, I remember.
This one? Cut 8, okay.
Yeah,
so
top left.
Yeah, so basically you need to come here and reverse this one. And let's see what's going on over there. Okay. What happened? Yep, so basically these are the last cuts. So it does the last cut, okay, here. It does the last cut, goes here, and then comes back, and then it drops the object somewhere, probably here, and you can pick it up. And I see that you haven't updated the location of this hot wire cutter, because in reality, the hot wire cutter is actually not there, it's here. And you need to actually measure the TCP here and update your code to reflect the exact location of the robot. And if that's the case, then I think these 2 points here should also, like the pickup and place, should also be slightly different from here. So right now, I think your robot is picking up everything from here. But I think in reality, it should be slightly here, like a little bit further down the road here. Or if you want to make it easier for your friends to put these objects in the correct place, it might be better to have it somewhere here with all those, brackets that I mentioned the other time. Yeah, you need to update these data in your file and make sure they are accurately representing the space in the lab.
Oh, and another question is like about the kind of inaccuracy, because yeah, I remember one cut is.
What was that again? Oh, the one cut was problematic. So let's see which cut was that one. First of all, I think there were some duplicated cuts. You need to take care of that part. That's also really important. So let's have a look. Okay. Here, one cut, 2 cuts, which I basically think were the same thing. Let's see. Do you have 2 cuts here? So 1 cut here So okay, let's starting from scratch. This is the first cut. That's fine. We cut it once. We cut it twice. You see that?
Okay.
So we cut this part twice. So somehow in your code, you should take care of this part. And both of them are seems to be accurate. Yes, no problem. And then let's see what will happen in your third cut. Okay, the third cut is not accurate. Somehow it's not exactly representing the geometry that you were working on.
Yeah, it's in
Fourth
the
cut
cut.
is and then the fourth cut is exactly the same thing. So third and fourth are basically the same thing. I think somewhere here also you have that problem with going through the wire. See that?
Yeah, I see.
Okay. This cut is fine. This is cutting that same thing again. Okay, I need to double check your file and see, and then it is inaccurate. This is fine. And this is fine. Somewhere in your code, you duplicated some of these cuts.
Maybe
I don't know. Oh, actually, do you remember that when I mentioned your cuts, I mentioned that some of them can be seen there twice. So these are all your tool passes. So you have this one. Okay, so first of all, keep your files a little bit. Okay, so just like so these ones. These ones. Okay. How many of them do you have? 15. That makes sense. And here, how many did you have? Another 15. Another 15 here. Okay, wait a second. So here we have these. And let me hide everything else. We have these targets. Okay, these are fine. Seems to be fine. Okay, these are fine. Okay, and in all cases, we have only 15. Okay, what was this one? Did you have this? Okay, no, that's new. And then we have everything from here, here. Okay, so it seems that your cuts are not duplicated here, but somewhere else they are all duplicated. Okay, so you have 8 cuts.
Yeah.
So there is something called toolpath decompose or data extractor. Okay. Okay, so let's see, how many targets do you have? Okay, so you have 8 paths with 16 targets. So I'm fine with that. This is not a problem. Seems like this part is correct. And then you join them here. So you have 8, 15, so it's going to be 120. Okay, this is also, I think I know what's gonna. Okay, this is still fine. Wait, how come that happens?
Maybe they are not repeating. Maybe the hand is rotating, so it's cutting the other side.
So let's count and see how many cuts you should have. So you should have how many sets of cuts? So you should have 1 here, 2, 3, 4, 5, 6, and 7. Why do you have 8?
I think I should have 8 because like 1, 2, 3, 4, 5, 6, 7, 8. Like
My
each side of the block they have 2 cards.
Why? So basically, let's see. What do I see here? So there's 1 here. And we have the second one here. So it's 2.
I think you miss.
4, 5. Yes, you're right. 7, 8. Yes, you're right. But how come we have those extra steps that are not exactly in your geometry?
Mm-hmm.
Oh, so this one is actually on this surface. We have 2, which I couldn't see. Okay, so one of them should be this one. So let's see, like in the first pass, it was 1. It was 2. These 2 are actually the same. Yeah. I'm pretty sure. Why is it happening? So let's see. Do we have 2 surfaces on this side? Like, am I making a mistake about?
I think maybe it's like in the first cut. Maybe I merge them twice. I don't know. I think I can just double check. I think it's not.
Oh, maybe something here. Let me just check. So where's the first one? The first one is actually here.
Can you repeat it? Can we see moving it again?
Sure. I remember there was a way to make it easier. So it's moving ahead and then moving ahead again. So let's check that. Let's check your targets. I think maybe when you were defining your targets, you merged them too much.
I think it's what I was saying, because as you can see, when it's cut in the first time, the direction is in one side, and when the direction of the cut of the 2 pieces is on one side.
So you think that the targets are rotating, you mean?
Yeah, maybe the arm is rotating, so it's cutting the other side, but it seems that it's rotating, but it's not.
Oh, so you mean like the target is actually rotating? Okay, so let me just put them
in one side. I'm sorry.
You're right. You're right, because here we have this extra triangle here, but on the other side we don't have it. Yes, exactly. This is correct. You're right. Okay, so it seems that the file is correct. It was my bad. Okay, so I think you're in good shape regarding this one. So the only part that you needed to change was that 90-degree rotation, and everything is going to be fine. That was a bit challenging, but thank you, Emilio, for spotting that. Maybe one solution to go ahead.
Like the inaccuracy cuts. Do we solve it?
You should actually solve that one also. Let's see what was the possible reason for that one. So I'm going to unhide everything, and then I'm going to immediately regret that decision. Where was that thing? It was in. It was in the layer.
Cut side 1.1, I think.
Is it this one? So this is the object. Okay. And let's see if your targets are actually completely matching. Okay, so briefly, I'm going to also hide whatever we have here. What is this object? Is it blocked or something? Okay, so let's see which target was the one that we were looking for. So let's go for ghosted possibly, or maybe X-ray. Oh, okay, so we want to see, I think, the target that we were missing. Okay. Let's see. These are fine. Okay, these targets are also pretty fine, no problem. And this is the top guy. Okay, this is the one that might be a little bit challenging. Okay. So let's have a look on the robot and see which one. Okay, so this one is the one that we have problem with. And compare it, this one and this one, I think it's on the other side. Yes. So basically, the one that I'm right now looking for is this part. Am I correct?
Mm-hmm. Yeah.
Okay. And the same thing that I see here. So somehow, oh, no, not that one. Let me hide those that I don't need. Definitely next time make your file a little bit cleaner. So
okay.
we can spot everything on time. Not this one. Probably this one. Okay. So let's see why these things are not exactly matching the target that we are looking for. Okay, so here it is. These are the targets. Mm-hmm. Let's track mm-hmm. them down from scratch. Like, what are the curves? So curves are actually pretty nicely arranged here. And you have a really cramped thing here, and you're actually not using them. So why not just delete them? Oh, no, my bad. With these curves. So these are the planes that this grasshopper thing generates. Yep. Mm-hmm. Okay, so these are the points. I'm going to do a trick here that might not be the most intuitive one. Okay. This is the surface that I have here. I'm just going to quickly make a hack to just double check everything. So this is the surface that I have. I'm going to introduce it to grasshopper. Okay, this is the surface. These are the points. And I'm going to evaluate those points on this surface. This is the surface. These are the UVs. And I want to see the normal. So these are this one, and these are the vectors. So it's the point, this is the vector, and it's the size. Yeah. 100 is too much, but oh no, not that one. Okay. Or maybe a better way is to just basically use SDL. Start, direction, and then use this one as SDL. Okay, so I have these ones. And okay, so these are the SDLs. Okay, you can see that they are not exactly matching the direction of this plane. You see that?
Yeah, I saw that. See.
The reason is that we are using just a basic XY plane. You see that? And then you just rotated that one. Okay, so this is not going to work. The reason is that these curves are actually not exactly aligned with XYZ. So you should actually come up with a solution to rotate these planes. To rotate these planes in the correct value. Let's see what we can do. So and not this one. Actually, give me a second. We may actually use C here. Did I make a mistake about it? Yeah. Okay, now they are aligned in that direction. Let me just figure out what would be a possible solution for this one. Because, okay, these rolling lines. Okay, so we want to have them like this. So these are going to be X, and that one is going to be Y. My bad here. Okay, so we have all these planes that are actually aligned. Yeah, the first one was correct. Let me just clean up the space here. So we have all these planes that are matching our, orientation of the surface. What we need to do here is to actually bring them up from this like position like this and rotate them, get like this. So we don't need to flip them around X. So I'm just going to move everything a little bit further. Ooh, that's super crowded. Okay, one suggestion, just to make everything a little bit cleaner, you can actually use some, for example, this. Okay, double click on this wire, connect this one, remove this, and wire display to hidden. Okay, and also the same for the speed. So basically, I'm putting everything in this speed placeholder, connecting it here. I don't need this one anymore, and wire display into hidden. So I'm not going to see those lines moving through the other ones. You can still see it if you click on it, but it makes everything way cleaner. Okay, so we have these. We don't need the flip. We need actually to rotate these targets in a plane, which is their own plane, or actually not in the plane. Rotate around an axis. Where is that? Okay, so this is the one. And we want to rotate these planes around these axes for 90 degrees or possibly minus 90 degrees. And again, it should be in degrees. So now let's compare it. So these targets here are actually matching that surface. Do you see that the red line always matches that geometry? This is what you need to do here. And here's the catch. The first one doesn't have it because these two curves are, colliding with each other in that corner, and over there, there's no way to make that decision for the whole model. But we can easily regenerate that one. Basically, let's see if it's the first or the last item. Okay, so it is the first item is actually null. Okay, so it's the first item that's missing. So we just need to move the first item to the second item to get there. Do you get what's happening here? So basically, physically speaking, like geometrically speaking, HAL is trying to connect this point to this point and make a line. This point and this point to make a line. But when it comes here, because these two lines are sharing the beginning point with each other, grasshopper cannot make a line between one point. It needs to have two points, even slightly closer to each other. But here we only have 1 point. Between 1 point, you cannot draw a line. You should always have two. So somehow this one is failed to make a target. So instead of giving you a target, it's giving you a null. You see that the first item is marked as null. That's the reason that you have this one here. So you need to somehow compensate for that one. My suggestion is to just basically grab this one and move it here. Okay. In order to do so, I'm just going to grab one of the targets, for example, target index 2 or index 1, which is the second item, which is not null. You see it? It's here. And just move it to this point. How can I move it? I can use different methods, to be honest. One way to do this is to actually, let's see if it gives me, okay. So I'm going to make a vector from 2 points. So basically I'm going to grab this item here and move it from this point, or basically copying it from this point to this point. I know that these 2 points are items 0 and 1 in the list of these targets. So I know that these points, there are 2 of them that I need. So item number 0. Oops, I need to have it a little bit better. Item 0 is my target. And item number 1 is the one I want to start from. And I'm going to say that start from here and from here. And I want to move this one. Okay. This is the object I want to move. This is the vector I want to move across. So, okay, now I have it. And I need to merge these things together to make sure that I have the correct order. Or actually, to be more specific, I'm going to replace the item. Because in this list of targets, items number 0 or index 0 is the one that I don't want to have anymore because it's a null and I want to replace it. Put this one here, but before that, make sure the data structure is the same. So I'm just going to check the data structure. So 0, 0, item 0, 0, 0, item 0. Now replaced with that one, everything seems cool. And we don't need those things anymore. So you have the flipping thing here. I'm not sure if you need the flip one, but let's try it. And let's see if it's right now working. If the robot is completely upside down, which means that everything is, nope, it's actually pretty nice and neat. But why is it cutting through this curve? Okay, so let's see. So it's right now cutting something. I'm not sure if it's the case. So let's see. Okay, it's cutting this. But we are looking for something else. So these two, oh, the part that we were looking for, which way is that? Okay, so we are cutting this small triangle here. Let's see where we can get to that small triangle. Okay, let's go and check all the cuts. Where is the time for that small triangle? Was it here? No. Is it here? Yes. Nope. Not here. Somebody help me with finding that. Okay, not here. So when did we cut this small triangle? Not here. Not here. Do you remember where was that?
I think like in the third card.
In the third card? But this is the small triangle. But I never see that being cut. Is this the one? No, it's cutting the other one, this big one. And this is the bottom part. This is the last cut. It's not there. Okay, so let's see. Where was the place we were working on? Here. And
from what I saw, I think it's the third one.
So let's see. So we have 1, 2, 3, 4, 5. It should be somewhere in the 5th one. Am I correct? Because in this order, it's the 6th one, which is this number 1 is the, okay, so let's see. It should be around like towards the end. Okay,
if you see number 6, the line, it's not like shaded. Maybe it's disconnected.
Okay, let's see. Number 6, you mean here?
On the merge.
On the merge?
Yes.
You mean? Oh, okay. So there's a delay. So maybe you're talking about this. You mean this?
Maybe take it out the green.
Hmm?
If you see number 6, the line is a different tone.
Right now, here, you mean?
Yes, in that one, in the merge. Oh no, it's okay.
Yeah, because on that time I was clicking on it. That's why it had a
maybe
different
I was
color.
thinking it was like the connector or something.
Okay, so there's an easy way, easy fix for this whole confusion, and that's called this. Okay, let's see. Yep. You see that it's upside down because we use that flip. But I think you need to make that 90-degree rotation. That's why. Okay, so first of all, it doesn't need that flip, I guess. So first of all, the 90-degree should be probably -90 to make sure that it is not doing anything stupid. Yep, actually it should be 0. Or is it? So it's trying to cut this piece. Oh, it's rotating around the wrong axis. Why that's the case? Okay, that makes sense. Okay, so it's the wrong axis. So let's see how we can solve this problem. Maybe it should rotate around. Oh, no, my bad, my bad. Actually, it should be SDL and start direction and L. It's interesting. In either cases, it's rotating around the wrong axis. Because it should be something like this, but 16 degrees is not something meaningful in this environment. But first, we actually need to make sure that it is not going upside down. We first need to put it the other way around. And I see that you have so many things connecting to each other here. So let's go here and here and here. And just use this one. So the robot is now in good, correct direction, and it's doing its job correctly. Do you see that? Now it's completely aligned. And the only thing we need to do, so the rotation was correct, no problem on that side. Now let's see if it's doing the cut correctly. So it was actually cutting that piece. The problem was that we were seeing it from the wrong direction. That's why we had that issue. So this is the correct cut. You see that? Like it's exactly cutting your object. And if you look carefully, it's completely okay. I think you need to do the same thing for every single surface that you have to make sure they are doing the right cuts. The reason that you saw that slightly different cuts was the fact that you were not compensating for that orientation. Let's see where else we had the same issue. Yeah, it took more than what I was expecting to debug every single one of these, but let's see. We still need to cover Machina because you need to do something extra with Machina. Okay, so I think this one is completely flat. based on your design, this one is completely vertical. So there's no problem with this one. I think this side here is fine. Also, this side here is fine. And the bottom cut is fine. The only part that you need to actually do this compensation is this plane here, as well as these two planes in the back. So these four are the one that you need to basically compensate for that error. And so basically, if I want to say like this one, oh, somehow this thing moves really slowly on my computer, on my iPad. So basically 1, 2, 3, 4, these four are the one that you need to compensate for those errors. So let's see, where did you have them? So first of all, let's mark the one that I edited. So first of all, the file should be really, really cleaned. Right now, it is not cleaned that much. And maybe you don't need this, you don't need this one, or maybe you need those two to make everything cleaner. Okay. And let's see, where else did you have that one? Okay, let's get back here.
Yeah, I had the name on the left top. I think like
so you have names here?
Yeah, it's the side 1.1, side 1.2.
Oh,
side
okay,
2.
great.
These are the four plane that maybe need compensate. And I think
Exactly.
you were in them. Yeah.
So you need to do two things. First, you need to make sure that they're all aligned, like the same method that I used here. Where's that? Where did I do that? Here. Wow. First of all, you need to, okay, let's make everything a little bit cleaner here for you by just moving everything from here slightly to the left. And the flip thing is not necessary in this specific case. You may need it later on. But here, the move command, vector 2 points, here, and here. Just a little bit cleaner. Okay, not the cleanest thing ever, but the only part that you need to actually take care is to add this XY plane. You need to connect this X to this plane from the rolling surface and add Z as the constant, and make sure that the rotation is correct. And then you will face the problem of missing plane over there. That's not that hard to handle. So let's try to do the same thing with this. So this one is another surface of interest. Let me hide whatever we don't need here. Okay, so this is the surface of interest. We need to have these things as x's. Okay. Yep, they are matching the surface. And then you flip them. Probably the flip is not necessary. And then you're almost good. You have no problem anymore. Here, you can even just skip this, but like, I don't know. You need to double check. And then you need to rotate them around their axis. So another rotate around axis. These planes around this axis with, again, make sure that it is 90 degrees, not 90 radians. Yep, and then probably fit it into flip, but I'm pretty sure that you don't need to flip them in that direction. And also make sure that you're correcting the last point that's missing, which is, in this case, going to happen in this corner. Yeah, that's it. You just need to correct these things in your file. So I think, oh, we have already covered 1 hour of the class in office hours. Okay, so you're fine with this part? Go ahead.
Since we don't have so much time, we can use this same hall and just change the shapes.
Yes, like, you should do that.
Okay.
Yeah, of course. And everyone, can you just like maybe email the file to me? I can like make the rest of the changes.
Okay. Let me just save this file. Okay, I'll send it to you in a moment. I have one suggestion. If you're booking time with Sam, does he have any time in the morning? Or it's all his times are in the afternoon?
In the morning of when?
Okay, because I want to make sure that Min is also available whenever you're cutting. So if anything goes wrong, she can actually step in and help you with the file, or anyone else who is doing the job. Because if you're going to the lab around 4 p.m., it's going to be 4 a.m. meantime. My suggestion is to actually do it in the morning, or sometimes that Min can step in and help you with the whole code, because she's the one apparently who knows exactly what's going on in this grasshopper file. Okay, so I'm going to stop sharing for a second so I can share this file with you through email. So save this file, save this file. Okay, so where is that one? Okay, so yeah, 1026. Just going to make sure that I'm not going to send you an old file. Okay. So these two files from my downloads, they modified the other way around. Okay. Okay, so since the file is a little big, it's going to be sent as Google Drive. Okay, good. So you'll have it. Okay, I think we are in good shape regarding that file. Let me just close everything. So, okay, so did you have a chance to open that Machina file that I sent you? Yeah, actually, you downloaded from the server.
Yeah, where should I open?
Okay, so wait a second. Don't open anything, because that's going to be a little bit challenging. Okay, so let me tell you what's going on here. So how many of you are familiar with a person called Jose Luis Garcia del Castillo? None of you? Interesting.
Could you say the name again?
Jose Luis Garcia del Castillo.
I don't think so, no.
A boxer.
Oh, no.
I know that one.
Jose Luis Garcia del Castillo Lopez. This is the full name. So, as you can see, the first link that shows up is this guy. So he's a friend of mine. He had his PhD or thesis from Harvard, I think last year or 2 years ago.
Wait.
He's a really nice guy. You may
I think
know
I watched
this
his lecture series.
That's the point. He is the guy. So despite his like not matching eye colors, he's also really, really good scholar. And whenever you see him and see one of his presentations, you will remember his name and his work. He is awesome teacher. And he is, okay, let me just, because I'm not going to remember the spell of his name completely. He has a really good YouTube channel. Yep, you can find it here. So he has this like whole YouTube channel with all these live sessions every week, I think, or every other week. And you can find a lot of fun stuff on his class. He's teaching programming with Grasshopper, programming with anything that you like. And he keeps producing these weekly or bi-weekly videos about computational design and all the fascinating things that happens around. I was working with him when I was at Autodesk Build Space in summer 2018, and he helped me a lot for developing some of my tools for that research project. And the reason that we are discussing him today is a project called Machina, or yeah, Machina. Oh, not here. Where's that? Okay, so let's go to GitHub. And let's see what are the repositories that I'm working on. And X Machina. Yep. So basically, Machina is a platform that let you work with robots in real time. This is a really interesting tool that he developed as a part of his research project and that was focused on inactive robotics. So basically, it means that you have interactions with the robot and you're not programming everything in advance, but you are actually programming the robot as everything goes on. The core tool that he is using is called this thing called Machina Bridge. And the way it works is pretty interesting. It runs a server on your robot, and then it runs another agent on your computer, which is this interface that you see here. And these two things are going to constantly talk to each other. So if you send a command on this console here in this type-based interface, your robot is going to listen and your robot is going to actually run it, which is pretty cool. It means that you don't need to define everything like in Grasshopper, export it, load it on the robot, and then run it. It means that you can actually say, robot, go ahead 4 centimeters, and the robot will go. It's just like having your teaching pendant in hand, but in your computer. You can define something in Grasshopper and change a slider, and the robot is going to move around. You can connect an Xbox controller, the robot moves around. You can write a Python code and integrate some computer vision stuff. It's still going to work, and it's fascinating. I integrated this system with computer vision running on a Raspberry Pi, and we could make a really interesting project about grabbing objects and identifying them and finding how the robot should actually go ahead and work with that one. The other good thing about this Machina Bridge is the fact that it's platform agnostic. So you can do it with, for example, ABB robots. You can switch to UR robots. I think he was working on some KUKA robots also, but the good part is that it is right now working with both of these things. Okay, what is this that you, oh, yes, I think actually the name comes from this movie. And how many of you have seen this movie? None of you have seen this movie?
I have.
Okay, it's a really creepy movie, but I think the name comes actually from this one. It is a fascinating movie. I really enjoyed it. So basically, my contribution to this project was the fact that I wrote the Python client for this one. So basically, you can write a Python code and it can listen to it and it can run your Python code on the robot. For example, if you define something, let me see. Let me just stop sharing my screen for a second so I can find that YouTube video because it's in my YouTube channel and I want to make sure that everything is clear here. Not this one, but okay, good. All my videos. Somehow my videos are getting slightly slower than I was expecting. Okay, it's here. Okay, now I can get back to sharing my screen. So this is the part that I'm really interested about using Machina, but we don't have enough time for this year to do this, but let's see. Okay, so basically, this is a project that I've done as part of my internship in 2018 with Mehmet Bermek and Shefki Topko. So basically, I'm not sure if I have shown you this video before, but basically we wanted to make a real-time interaction, not real-time technically, but kind of like integration between the robotic fabrication process and a Revit, a structural fabrication workflow. So basically we had this script that could look at a frame structure in Revit and then produce a data sheet that gives you the exact dimension of each piece of timber structure that you need to have. And then it could send the data to a CNC machine to cut all the elements and details on each of these pieces. And then it would let you put some marks on each of these details so the robot could actually find them and work with them. So we designed some gripper for these robots, so the robot should actually be able to grab these items from the correct place. But at first it needed to find these elements and figure out what is the orientation of them, and then make a decision about where should it go to grab them. So basically these things are called Aruko markers. And when a robot looks at those elements, looks at those Aruko markers, and the computer vision algorithm then can tell what's the distance between the camera and these Aruko markers, because it knows the size of them and it knows the patterns on them. So it can actually say that, okay, this is like 2 meters away from me. And based on the perspective, it can say like, what is the orientation of that one? So basically, each of these Aruko markers are defining a target object for the robot, and the robot can actually go over there and grab it. And then we designed some details to take care of the like 5-millimeter discrepancy that's happening over there. So Vila is understanding this problem because she's working on some drone robotic fabrication. So she knows exactly what do I talk about when I say like there are discrepancies. So here on the right, you see that I'm using Python on Jupyter Notebook, and this is the feed of the camera. The camera sees that these gray objects are the frame that this piece of wood is installed on. And these 3 markers, the red one, yellow one, and the blue ones are those markers on a piece of wood that we have. I think the robot could only see the blue one and the red one, and it calculates the middle one, which is the place that this gripper should go and grab the object. But everything happens in Python. How we can send the data from Python to the robot to actually go ahead and grab that object. Machina bridge is the part that takes care of this computer vision algorithm and robotic control. So this is the project that we've done. We just randomly put these objects on this platform. And as you can see at the middle of the platform, there is actually one marker. So this marker at the middle was working as the work object. The robot would look at that one and say, okay, this is the work object that I should define in order to grab all these elements. And then once it was aware of this, the location of this work object, it could actually locate the other ones in relation with that one, pick them up from random places on this platform, sort them here, and then it would actually put them in the correct order in the fabrication site. So think about it in this way. There is a truck that brings all these pieces from the factory. The robot needs to sort them and then bring them in the correct order. And then somebody can actually help the robot to fix them in their correct place. So this was a really accurate project. We were not expecting such level of accuracy, but it was really interesting. You could assemble this whole thing in like half an hour or so if you wanted to do so. But you can see that there are some like extra details here to work on this one. It was really interesting. But the reason that we could do this whole real-time interaction with the robot was the fact that we were using Machina as the bridge between our computer vision system and this robotic control. So since we are not going to use the robot anymore after this assignment, we are going to do some like virtual working with this workflow. So let's go ahead and do it step by step. I'm going to close whatever I have here because it's really important to follow exactly the steps I'm taking. As I mentioned, this Machina thing is running a server on your robot, and it needs to communicate with the robot. And it's really important to do these steps one by one to make sure that it's doing its job. So if you have opened that file that I gave you and you unzip it and open it like this in a folder, you'll see that there are lots of files here. You're not working with any of them except this one, machinabridge.exe. Should I do the same thing as always and increase the size? Of course, I should do that. Display setting. Maybe I should make it 200%. Okay, so everything is like oof, in my face. Okay, so I put it here. Am I right? Yep. 812 here. Okay, so go ahead on this file, right click and run it as an administrator. Okay, when you do this, you will see this window. So basically, it's a Windows app that has this interface, and we are going to start working with it in a moment. But just let me tell you what's going on here. So basically, there's this part on the left that defines what is your robot, how are you going to communicate with it, and it's going to tell you if anything else is communicating with this bridge. So bridge is the middleware. We may have a robot on one side, you on the other side, Machina is going to be at the middle. Then there is this part that actually tells you what's the status of the robot, what's the speed, what is its position, how's it working, basically what's up. And then here in the queue, it tells you what's exactly being run on the robot and what has already been run and what's going to run after this. And then here in the console, it's going to tell you what's going on. And this is the magic part that you can actually type your commands. So far, so good. You have just interface, nothing special happening here. But the magic happens here when you open RobotStudio or connect your computer to a real robot. You're going to do it with RobotStudio because RobotStudio is the only thing we have right now. I'm going to put this window on the right, keep RobotStudio on the left. I'm going to do a couple of things that should exactly follow me. I'm going to make a new station. And I'm going to continue with our friendly, lovely 120, but I'm not going to hit create. I'm going to hit this option that says customize options, and then I hit create. The reason for that is the fact that we need to add a couple of extra options to our robot that's not by default installed on the robot, because ABB charges you a couple of $1,000s for these options, and I'm so glad that all of our robots are already equipped with these options. What are those options? If you hit that customize option, this window will pop up, and you have two parts that we need to play with. First, communication. Communication, and here you should select PC interface. Basically, it says that your robot is going to communicate with your computer through an Ethernet cable. And we know that the 6640 and 4400 robots in the lab are connected to that computer that we have in the lab. So this option is already available, but in RobotStudio, we need to make it active on the robot that we are right now making. There's also something else called engineering tools, and it's called multitasking. So basically, it runs two tasks simultaneously. You have already seen it on 120 robot that we have in the lab. It has two tasks running simultaneously, and you should be careful which one is going to be the one that you're using. So if I hit yes, my computer is going to start that virtual controller, and it's trying to somehow communicate with the robot that's going to be on RobotStudio. The interesting part is the fact that despite the robot in the RobotStudio being a virtual one, it still has all the options, all the networking capabilities and other stuff to communicate over a virtual network. So if you hit OK, it's going to bring you the robot. Classic 120, no problem, everything is fine. OK, so as soon as you get to the green light on RobotStudio, we can continue working. So do you all have the same setup? RobotStudio on the left, Machina on the right, or something similar?
Yeah.
Awesome.
Yes.
So here's the magic. We need to somehow connect this robot to this thing happening here, Machina. How we can do that? We actually go here, make sure that we have an ABB robot. We make sure that the manager for the connection is set to Machina. And when you set it on Machina, it's going to automatically lock this IP address and the port number. We are doing this because we are working a virtual robot. But if you go to the lab and start working with the real robots, we need to actually manually change these numbers. For example, set this one to 192.128.0.20, I think, and then keep the port the same. But don't worry about it. You're not going to do it with the big robots. So just leave it as Machina. Machina is going to take care of everything. And I'm going to hit connect. But while I'm doing it, keep an eye on what's happening here. Actually, to make it even better for you, I'm going to clear everything here. And just to clarify, I go to Rapid and check what's going on in the Rapid side on this robot. You see there's nothing in Rapid. So I'm just going to also make a vertical group here so you see what's going on in Rapid, what's going on with the robot, and what's going on in this panel here. So getting back to Machina, I'm going to connect them together. As soon as I do so, Machina is going to connect with RobotStudio, tries to make its magic. And if everything goes well, and if you have run this Machina as an administrator and you don't have a firewall that blocks it, you will see that on the right side, it says, OK, I'm working with this robot. I'm communicating with it, and I can see what's going on with the robot. It's telling us where is the position of the robot, where is its orientation. It's going to tell us like what are the axes connected to this one. It also tells you about the speed, precision, and everything. So basically, you have full information about this robot. And this robot is right now up and running. And then in the Rapid side, you see that this Machina driver is running on this robot. So basically, when you hit connect, Machina connects to RobotStudio, delete the Rapid code, install its own server, and tries to communicate with it. And if you look at this code here, it is a little bit complex. and it's not an easy text. So let's leave it as it is and let it work the way it should work. So we are not going to interfere with it. We are just going to stay here, make sure that everything is fine. And as you can see, it says the program has already started. So that code is running right now on your robot. So let's see what we can do here. So for example, we can say that move for 10 millimeters in X direction, 10 millimeters in Y direction, and 10 millimeters in Z direction. And then I put this semicolon and I hit enter and the robot moves. That's the beauty of Machina. I can write the command here and it's going to run it. And as soon as I run that command, you will see that this line here becomes green, which means that, okay, you gave me this order, I ran this order, and it's done. Go for the next one. So if you hit up and down arrows on your keyboard, it's going to bring the last commands that you have used. And it's really handy because sometimes you want to repeat a command for multiple times. It's actually pretty good. I'm going to ask the robot to come back so I will have more space. So I'm just going to ask the robot to move for -1, -10, -10. As soon as I hit enter, it's going to tell me, okay, the robot is going to get back into its position. So far, so good. Everything seems fine. And the point here is the fact that it's not just about moving the robot in a specific direction. There is a library of commands that you can use. It's not going to be as extensive and comprehensive as what you could get, for example, from the core rapid commands, but it's really handy if you want to do something general. So let me for a second stop sharing and getting back to Canvas so I can give you students. Okay, I need to get back to student view again to give you those files. Where's that? Okay, good. So if you get back to your files and go to Machina, you also see, oh, you don't see it there. Okay, wait a second. I need to drop this file for you also. Here. And I'm going to update that file for you. Yes. So I prepared this cheat sheet for Machina. Oh, you can go ahead in the Machina page in our file section. And if you go there, there's this file, the PDF file that's called Machina cheat sheet. So let me just bring back my screen so you can actually get to your canvas, and then you can go to Machina, and over there you have this file that's called Machina cheat sheet. And inside of that, you can find all these discussions for command line based communication with Machina Bridge. So for example, if I put this cheat sheet here, because I'm not also an expert on this file and I'm not remembering the whole syntax, you can actually change some of the properties and some of the actions of the robot. For example, precision is basically the zone value that we have in our rapid code or in HAL. And the point is, we can actually use this command, precision 2, for example, 10, which means that we are going to have a Z value of 10. And if I do so, you'll see that this precision here changes. There's another command that's called precision, and then it increases your precision by a number. For example, if I say precision 10, it's going to add 10 to 10 and makes it 20. So in the language of Machina, whenever you have something like speed, precision, or something like that, it means that you're going to add something to the currently available value. But when you say speed to something, or precision to something, or move to something, it's going to use that value as absolute value and set everything to that number. So for example, if I set precision to 10, it's going to add set Z as 10. But if I say precision 10, it adds 10 to the current precision. So let's go and test some of these things. So for example, I'm going to set speed to 150 and semicolon at the end. You see that the speed becomes 150. And then I can say that it's speed another 10. You see that the speed increases by 10. Okay, so this is some sort of like tradition that they have in Machina. I can set my motion mode to, let's say, joint, because I want to make some move J. As soon as I do this, it's not doing it yet because this is going to happen after I make a motion command. So let's see what will happen if I move the robot for another 20 minus 20 and minus 30. Hopefully nothing is going to go wrong here. And then the robot does the whole job, speed gets updated, and the motion becomes joint. This is actually pretty cool, but to be honest, what's the point of writing commands line by line and working with a robot that we can do the same thing with the joystick on the teaching pendant? What's the point? The point is, Breach has a lot of potentials for getting integrated with other things. You see here something interesting that says Breach part. This is the fun part. It uses a protocol called WebSocket. And WebSocket is a protocol that runs on the background that let you communicate between different apps that you have on your computer. For example, if you work with Revit and then somehow you connect it to Rhino and find a plugin that connects Rhino and Revit, most probably they are communicating through WebSocket. If you use Runway ML and it communicates with your Photoshop, probably a WebSocket. It's really secure, really fast, quick communication method. Which brings us to this idea. Can we somehow connect this Breach to Grasshopper and communicate between these two things, like Grasshopper to Machina to robot, and have some sort of like real-time interaction? And the answer is yes. Basically, the answer is yes, because that's what we are going to do today. So if you get back to your files from RobotStudio, you will from Canvas, you will find a folder that's called Machina. If you don't want to go all the way that direction, there's always these things called Food for Rhino or Food for Rhino. And over there, you can search for Machina, and it brings you this. So basically, there is a plugin that runs Machina by Garcia del Castillo on your Grasshopper. You can download this file from Canvas also. So at the beginning of the class, I asked you to do so. So if you go to this Food for Rhino Machina, you can download the files here, which is basically Machina for Grasshopper. If you do so, it's going to show you this folder. If you open this folder and unzip it, there would be a couple of files here. You only need these three. You can actually select these three files and copy paste it in the component folder of your Grasshopper. So let me just copy paste these things in my desktop. I'm going to make a new folder and I will call it GS Machina. Okay. Okay, so you don't need the README file, but if you go to your Grasshopper, give me a second until I open this one. So it's basically the same method that you use to install anything on Grasshopper with the catch, which I'm not sure is the catch that you should always be concerned about, but oops, that one, this one. So if you open Grasshopper and you get to the special folder, which is the place that you keep all of your plugins and cool stuff that helps Grasshopper to be the almighty Grasshopper, you can actually access that folder from File, Special Folder, Component Folder. You might be familiar with this because this is the same place that you have already installed your HAL and HAL license. You can basically copy paste those three files from here. Just copy paste these three, copy and paste it here. I'm not going to paste it because I have already pasted them here, so they are already available here. So if you go here, you see that, where are they? So one of them is here, Machina DLL, Machina Grasshopper, and WebSocket Sharp. Where is the WebSocket Sharp? Okay, these three files. They should be copied here, but there's one step further. You should right click on them, Properties, and make sure that there's one option here that says Unblock, because I have already done this. It's not there anymore, but you should make them unblocked. And it's exactly here. So you right click here, properties, and it should show up here. But since I have already done this, it doesn't show up here. I think if I do it here, it should show up. Yes, you should unblock them and copying them in this folder. Once you do that, and hopefully you had enough time to do it, you can actually start using Grasshopper and Machina all together. So let's see, where is Machina? For me, it doesn't show up here, so I need to somehow. Okay, it actually should show up here because I saw it the other day. Yeah, here. So basically here, it does a really, really interesting job. It has one section that's called breach. So Machina, basically the Grasshopper engine for Machina almost does the same job as HAL, but it does it in a totally different mindset. So if you want to switch from HAL to Machina, there would be a learning curve. You're always welcome to do this, but it's slightly different, and it doesn't have an IK solver and visualizer. That's why we are staying with HAL. Anyway, so this breach section of Machina is the beauty of Machina. I love it. So basically, it says that I can communicate from Grasshopper into your breach, and from breach into your RobotStudio or any real robot that you might have connected to that one. Why did I put this one here? Okay. Okay, so we have this here. Let's bring up the Machina server here. And I want to use this connect component to make a connection between my Grasshopper and the breach on the right side. So you can see here, it says no client connected. And it means that this bridge is not connected to anything. But it says this is the address of the server. I copy this text here. So basically right click, copy, and I paste it here. And I don't hit enter at the end. You remember, it's a really bad idea to hit enter after doing this. Okay, I'm connecting this one to here. So it knows where to look for in order to connect to. And I'm going to say that this is Grasshopper breach, even ITAR, to make it more complex. So this is the name. And I'm going to say Boolean toggle as a switch here that makes connection between this Grasshopper thing and the breach. So this is the on and off switch. As soon as I hit this one, you see that it says Grasshopper breach ITAR is connected to breach. Okay, so we are connected, but what else can we do? The point is we can actually listen to the breach. So this is the component that automatically listens to your breach and shows you some information about your robot and what's going on and the whole situation. So yeah, this part is good. This part is good. Everything is fine here. So this is something that's going to constantly listen to our breach, but actually the cooler part is to send something to breach. So basically, this component here is going to connect to this specific breach here, and it's going to send it an action or a list of actions. Actions in the language of Machina is a set of commands. It's equal to the same thing that we had in HAL as motions or commands. So for example, here I can ask it to do some movements. So move from point A to point B. And again, it has absolute value or it has a relative action. So I just want to ask my robot to move for like 10 centimeters in this direction, 10 in this direction, and 10 in that direction. So basically, I can make a vector. And basically, I want my robot to move for 10 centimeters or millimeters. Let's say like 25 millimeters in X direction. And maybe the same thing in the Y direction and a little bit in the Z direction. Maybe a little bit further in the Z direction. And I want to send this command to my robot. So far, so good. It seems that everything is pretty much practical. Okay, I'm just going to rearrange my screens so we can see what's going on. Okay, my RobotStudio is going to be here. I'm going to make it a little bit smaller, probably by just hitting it here. I'm going to keep my grasshopper down here. I'm going to zoom back so you can actually see what's going on. And we have our bridge here. So as you can see, this switch here tells us if we want to send a command to our robot. So beforehand, I use this toggle switch, which basically stays on until we say off, or stays off until we say on. But in this case, we are using this, bottom that only becomes true when we hold it and becomes false when we release it. So I'm going to use this one. Okay, and I'm going to see what's going on here. So it says nothing has been sent. I hope you can actually read it. And it's going to send me what we are going to send. Okay, so as soon as I hit send, the robot is actually listening to me here and goes in that direction. Actually, I want to flip that vector because maybe multiply it by -1 because I want the robot come back at this moment because I don't want to move it too much to that direction. So I'm going to say -1. So this time, if I send the command to the robot, you see that the robot comes back. If I change this one to 1, the robot goes ahead. So maybe the better way was to actually, not that. I did so many different things that were all wrong. Okay, so this one is -1 or anything in between. Okay, so the robot is right now too far. Let's bring it back. Okay, it seems that we have this option to control the robot. It can go whatever we want. So like, let's say that we want to go a little bit further in X direction and go way up in the Y direction. And we want to do it in positive direction, the robot goes. We can do it in the other direction, the robot comes back. And it doesn't matter if it's in RobotStudio. It's exactly what will happen if you do the same thing with the real robot. If you connect your computer through an Ethernet cable to the controller of one of these robots, it doesn't matter which robot it is, it's going to do the job. It's going to do the job. And everything gets a little bit funnier if you start using this, which is basically an Xbox controller. Oh, you cannot see. An Xbox controller. And if you don't know, there's actually a plugin for this one to work with Grasshopper. And the plugin is in your Canvas folder. And I think this thing is going to work. It says my Xbox controller is connected. I'm so mad that it's not showing it correctly. And it reads exactly what's going on with all of my switches and bottoms on this robot, on this Xbox controller. So you see that the number is right now 50. It should be, okay, left thumbstick, X. It should read this one. So let me just put a timer here. So it's going to read the value from my controller. Come on. Okay. And the interval should be set into like 100. Yeah, you can see that when I'm moving this left and right, it reads between -50, between 0 and 100. So I can actually subtract it because that's a really big number. Or maybe I can actually use evaluate, which is gives me this option to go for a formula. And I can say that, okay, read this number from here and X divided by Y, or maybe X minus 50, because the numbers are between 100 and 0, and 50 is basically the middle. I'm subtracting everything, so I will have a number between -50 and +50. So whenever I'm not holding this switch, it's going to be 0. Whenever I'm moving left, it's going to be -50. Whenever I'm moving it to the right, it's going to be +50. And Y is the factor that I can divide everything by, because 50 is actually too much. So yeah, I have this number here. I can do the same thing with the up and down arrow. So whenever I'm holding my Xbox controller and start playing with it, you see that when I'm changing the numbers, like when I'm moving left and right, it goes with this number, -20, +20, actually the other way around. And when I'm moving up and down, it gets these numbers. I can actually go for a bigger scale factor, because maybe something like 10 would be better. Now it's like every time I'm sending the command, it's just going to move for a couple of millimeters. And then I can grab these things and I can connect them to this XY thing. And instead of sending the commands like one by one, like what you see here, I can actually get a little bit. Okay, so let's go for a little bit further. The robot goes up. Oops. And maybe the robot should actually come down for a bit. Okay, good. I'm going to remove the Z value. And instead of having this switch here, I'm going to put a bottom here, a toggle here. Now everything gets crazy. Now when I'm playing with this, the robot is actually replying to my commands. No problem. You see that? I'm just playing with my Xbox controller and my robot responses. And this is a really interesting property that we can get. And based on, like, it's right now based on the amount that I'm playing with this, joystick, it's sending different values to the robot. And I think right now I'm getting too close to the body of the robot. I need to go a little bit further. But you can actually work with anything. Like, this is an Xbox controller, but you can actually go for anything else. You can actually connect, maybe if you're a hacker, you can actually connect it to your Apple Watch and it's going to track your hand gestures. If you're so fancy, which is something we are going to be in the next couple of weeks after the break, we are going to integrate some machine learning algorithms to, for example, track your hand gestures and do something for you. Or we can do whatever we want. For example, we can use an image classifier to distinguish between a cup and a mouse, and then it's going to guide the robot to pick one of them, which was a huge problem like 10 years ago, but right now it's like at your disposal that you can actually work with it. And it all comes to this open source software that we can work with. So there are lots of potentials in this Machina breach, RobotStudio, grasshopper, real robot interaction that we are going to investigate a little bit further in the weeks after the break. However, what I'm going to ask you is something serious here. So between today and next week, when we are going to work with Runway ML, I'm asking you to watch this video. So this workshop by Jose Luis Garcia, is about using Runway ML and somehow connecting it to Machina. And it is fun, and it's going to be really interesting. And my suggestion is to watch this video before coming to the class. And then in the class, we are actually going to do something similar to this one, or maybe exactly replicating it. And my suggestion is to actually go ahead, download Runway ML. You don't need to pay anything if you just want to use it for practice. If it says like get subscription and everything, don't do it. You don't need it for now. But grab one of these, watch this video, and try to get yourself familiar with this workflow. And then we are going to go further on next Tuesday, and then we are going to work a little bit further in the next couple of weeks before the semester is over. Okay, that's it for today. I hope everything was clear and exciting for you as it was exciting for me. And just let me know if you have any questions or if everything is fine. Any question?
Just one thing.
Mm-hmm.
I think, well, I got like a little error coming up when I was trying to open up Machina Grasshopper.
Okay, what does it say?
Local SDK. Well, it says that the
the
it was
SDK
built against a new minor version of Grasshopper SDK. So.
So.
same as me.
Oh, can you send me a screenshot of that one or share your screen for a sec?
I can do that. Yeah.
Great.
Let's see.
That's something a little bit fishy.
Oh, not this one.
Okay. Got it. So Mechanical Coding library was built against a newer minor version of Grasshopper SDK. So when you hit close, is it going to do the job or it's
No,
just...
this is after I reopened it again.
Oh, okay. Let's see.
If I hit close.
That's a little bit odd. Okay. So it happens every time you try to open. Oh, wait a second. So you have Rhino 6 and you have Grasshopper build 100007. And did you, okay, can you put that Machina component again? Let me see what, can you reproduce the same error?
Oh, you want me to close out again?
No, just, so it doesn't load the Machina at all?
No.
Did you unblock Machina objects?
I did.
Okay, can you, okay, just send me a screenshot of that one. I'm going to send it for Jose Luis and see if you can actually find a solution for it.
Okay.
Because probably have already seen this. He has already seen this one. Okay, great. So hopefully we can solve that problem before the next session and everything goes well on that side. So try to finish your homework as soon as possible. Try to keep your break as a real break. And update me whenever you face a problem or you need help or if you are facing some challenges in the Grasshopper definition. Is that okay?
Yes.
Great. Okay. See you after the break. Have fun and stay in contact.
Right.
Bye. Thanks.
Goodbye.
Goodbye. Thanks.